Hi everybody, welcome to Dr. Manny's YouTube Learn Shops. This session will deal with part 1, looking at inferential statistics and hypothesis testing. The learning objectives for this are basically, first of all, to explain inferential statistics, describe the assumptions of statistical hypothesis testing, and define components in hypothesis testing. What are inferential statistics? Well, inferential statistics make predictions based on the data. With collected data from a sample, inferential statistics help to understand the larger population from which the sample is taken. It's got two main uses: making estimates, for example, the mean SAT scores for all grade 6 students in Australia, and testing the hypothesis to draw conclusions about the populations. For example, relationships between SAT scores and family income. Just to recap, let's remember that descriptive statistics describe the data set. The distribution concerns the frequency of each value. The central tendency concerns the averages of the values. The variability concerns how spread out the values are. In descriptive statistics, there is no uncertainty. The statistics precisely describe the data collected. If the data was collected from an entire population, you can directly compare the descriptive statistics to those from other populations. For example, you collect SAT scores of all the 10th school graders for 2 years. You can use descriptive statistics to get an overview of the school scores in those years and then compare the mean SAT scores with the mean scores of other schools. With inferential statistics, it allows you to make assumptions based on the data set. You acquire data from samples because it's too difficult or too expensive to collect data from the whole study population. You sample to make reasonable guesses about the larger population. It's important to use random and unbiased sampling methods. If your sample isn't representative of the population, then you can't make valid statistical inferences. For example, you randomly select a sample of 10th school graders in your state. You collect data on their SAT scores. You make estimates and test the hypothesis about the whole population of 10th school graders in the state based on your sample data. What are some of the definitions? Let's review again. A statistic is a measure that describes a sample. Example, the sample mean. A parameter is a measure that describes the whole population. Example, the population mean. Sampling error is the difference between the true population values, the parameters, and the measured sample values, statistics. The confidence interval refers to a range of values around a statistic that is believed to contain, with certain probability, at least 95%, the true value of that statistic or population value. When we look at hypothesis testing, we've got to consider the following. A hypothesis is an approximate explanation that relates to a set of facts that can be tested. There are basically two types: the null hypothesis and an alternative hypothesis. The research generally starts with a problem. The hypothesis provides the researcher with some specific restatement and clarification of the research problem. The criteria of the research problem is in the form of the null hypothesis and an alternative hypothesis, which should be expressed as a relationship between two or more variables. The null hypothesis and alternative hypothesis are useful only if they state the expected relationship between the variables, or if they are consistent with an existing body of knowledge. They should be expressed as simply and concisely as possible. Now, the purpose of the null hypothesis and the alternative hypothesis is to provide an approximate description of the phenomena. The researcher, with a relational statement that directly can be tested in the research study. The framework for reporting the inferences of the study: the purpose is to behave as a working instrument of the theory. The data is to prove whether or not the test is supported, which is separated from the researcher's own values and decisions. It directs the research. Both the null hypothesis and the alternative hypothesis have symbolizations. The null hypothesis is generally denoted by HO or H0, and it states the exact opposite of what the researcher predicts or expects to find in the research. It basically defines the statement which states there is no exact or actual relationship between the variables. The alternative hypothesis, which is denoted by either H1 or HA, makes the statement that suggests or advises the potential result of an outcome that the researcher wants to find or may expect. So, for example, you can have a comparison, which I'll just call a legal comparison. A criminal trial is an example of a hypothesis testing without statistics. In the trial, a jury has to decide between two hypotheses. HO, the defendant is innocent until proven guilty. HA, the defendant is guilty according to the prosecutor, who must convince the jury. The jury doesn't know which hypothesis is true and must make a decision on the evidence that's presented. The null hypothesis always states that nothing is going on, there's no difference, there's no relationship, there's no treatment. The alternative hypothesis always states that there is a difference, there is a relationship. The statistical significance of the null hypothesis is a p-value less than 0.05 is statistically significant. It indicates strong evidence against the null hypothesis, as there's less than 5% probability the null is correct. Therefore, we reject the null hypothesis and accept an alternative. A p-value higher than 0.05 is not statistically significant and indicates strong evidence that the null hypothesis is acceptable. This means that we retain the null hypothesis and reject the alternative hypothesis. Note, you cannot accept the null hypothesis. We can only reject the null or fail to reject it. So if we return to the legal comparison, these are the critical concepts. There are two hypotheses, the null hypothesis and the alternative hypothesis. The procedure begins with the assumption that the null hypothesis is true. The goal is to determine whether there's enough evidence to 1. Deduce that the alternative hypothesis is true, and 2. Judge the null hypothesis is not likely to be true. Therefore, there are two possible decisions. Conclude that there's enough evidence to support the alternative hypothesis and reject the null hypothesis, or conclude there's not enough evidence to support the alternative hypothesis and fail to reject the null hypothesis. With hypothesis testing, we can have judgment errors. So there can be a type 1 error, and this occurs when we reject a true null hypothesis. A type 1 error occurs when the jury, for example, convicts an innocent person. So a type 1 error means that there's a p-value of 0.05 or 0.1. We want the probability of a type 1 error to be small. For a criminal trial where a conviction results in the death penalty, we want 0.01 beyond a reasonable doubt. A p-value of 0.05 indicates that you're willing to accept a 5% chance that you are wrong when you reject the null hypothesis. You can reduce your risk of committing a type 1 error by using a lower p-value. For example, a p-value of 0.01 would mean there was only 1% chance of committing a type 1 error being wrong. When we look at a type 2 error as a judgment error, this occurs when we don't reject a false null hypothesis. And so, for example, in the legal analogy, a type 2 error occurs when the jury acquits a guilty person. The probability of committing a type 2 error is equal to 1 minus the power of the test, also known as beta. This is a false negative, like an alarm that fails to sound when there is a fire. You should be aware of it. Hypothesis testing. First thing to consider. Hypothesis testing is a formal process or procedure for investigating ideas using statistics to test specific predictions, that's your hypothesis, that come from your theories. There are 5 main steps. State the research hypothesis as the null hypothesis and an alternative hypothesis. Collect the data in a way designed to test the hypothesis. Perform an appropriate statistical test and decide whether the null hypothesis is supported or rejected, refuted. Present the findings in your results and discussion section. Step 1. State a null or alternative hypothesis. After developing the initial research hypothesis, the prediction that you want to investigate, restate it as the null hypothesis and the alternative hypothesis so that you can test it mathematically. The alternative hypothesis is the initial hypothesis that predicts a relationship between variables. The null hypothesis is a prediction of no relationship between the variables of interest. So for example, you want to test whether there's a relationship between gender and height. You formulate a hypothesis that men on average are taller than women. To test this hypothesis, you have to restate it. The null hypothesis, men are on average not taller than women. The alternative hypothesis, men are on average taller than women. Step 2 is to collect the data. So for a statistical test, validity, sampling and data collection must be the correct design to test your hypothesis. If the data are not representative, you can't make a statistical inference about the population of interest. And to test the differences in average height between men and women, the sample should have equal proportion of men and women and cover a variety of socio-economic classes and any other variables that might influence average height. You should consider the scope, whether international or local. A potential data source might be census data, since it includes data from a variety of regions and social classes. Step 3 is performing the statistical test. This is based on the comparison of within-group variance, how spread out the data is within the category, versus between-group variance, how different the categories are from one another. If the between-group variance is large enough that there is little or no overlap between the groups, then your statistical test will reflect that by showing a low p-value. This means it's unlikely that the differences between these groups came about by chance. The statistical test will be based on the type of data collected. So for example, if we're doing a t-test, it's to see whether men are in fact taller than women. This test provides an estimate of the difference in average height between the two groups. The p-value showing likely that there is a difference if the null hypothesis of no difference is true. The t-test shows an average height of 175 centimeters for men and an average height of 161 centimeters for women, with an estimate of true difference ranging from 10.2 centimeters to infinity. The p-value is 0.002. Step 4, you've got to decide whether the null hypothesis is supported or rejected, refuted. Based on the outcome of the statistical test, you'll have to decide whether the null hypothesis is yes or no. You'll use the p-value generated for refuting the null hypothesis, which will be 0.05, when there's less than 5% chance that you would see these results if the null hypothesis were true. If you find a p-value of 0.002 is below your endpoint of 0.5 in your analysis of the difference of the average height between men and women, you reject the null hypothesis of no difference. Step 5 is presenting the findings. The findings will be presented in the results and discussion sections of the research paper. In the results sections, give a brief summary of the data and a summary of the results of your statistical test. For example, the estimated difference between group means and the associated p-value. In the discussion, you discuss whether your initial hypothesis was supported or refuted. When we look at hypothesis testing again, hypothesis or predictions are tested using statistical tests. Statistical tests also estimate sampling errors so that valid inferences can be made. Statistical tests can be parametric or non-parametric. Parametric tests are considered more statistically powerful because they are more likely to detect an effect if one exists. We'll be discussing parametric and non-parametric tests in other sections as well. So, a parametric test makes the following assumptions. The population that the sample outcomes from the following normal distribution of scores. The sample size is large enough to represent the population. The variances, a measure of spread of each group being compared, are similar. If data violates any of these assumptions, non-parametric tests, which are also referred to as distribution-free tests, are used because they don't assume anything about distribution of the population. When we look at statistical tests, essentially there are three test types: comparison, correlation, and regression. With comparison tests, this assesses whether there are differences in the mean, median, or rankings of scores of two or more groups. Which test suits the aim? Consider whether the data meets the conditions necessary for parametric tests, the number of samples, and the levels of measurement of variables. Example, mean can only be found for interval or ratio data. Median and rankings are more appropriate measures for ordinal data. Correlation tests. They determine the extent to which two variables are associated. Pearson's R is the most statistically powerful test. Spearman's R is appropriate for interval and ratio variables when the data doesn't follow normal distribution. Chi-square test of independence is the only test that can be used with nominal variables. Regression tests demonstrate whether changes in predictor variables cause changes in an outcome variable. Which regression test is used is based on the number and types of variables used as predictors and outcomes. Commonly used regression tests are parametric. If your data is not normally distributed, you can perform data performance transformations. Data transformations help you make data normally distributed using mathematical operations, the square root, for example, of each value. So in summary, there are 5 steps for hypothesis testing. Specify the null hypothesis, specify an alternative hypothesis, set the significance level, calculate the test statistic and corresponding p-value, and then you draw a conclusion. Step 1. Specify the null hypothesis. The null hypothesis is a statement of no effect, relationship or difference between two or more groups of factors. In research studies, a researcher is usually interested in disproving the null hypothesis. So for example, there is no difference in intubation rates across the ages of 0 to 5 years. The intervention for control groups have the same survival rate, or the intervention does not improve survival rate. There is no association between injury type and whether or not the patient received an IV in the pre-hospital setting. Step 2. Specify the alternative hypothesis. It's a statement that there is an effect or difference. This is usually the hypothesis the researcher is interested in proving. The alternative hypothesis can be one-sided or two-sided. Researchers often use two-sided tests even when the true hypothesis is one-sided because it requires more evidence against the null hypothesis to accept the alternative hypothesis. So for example, The intubation success rate differs with the age of the patient being treated, two-sided. The time to resuscitation from cardiac arrest is lower for the intervention group than the control group, one-sided. There is an association between injury type and whether or not the patient received an IV pre-hospital setting, two-sided. Step 3 is to set the significance level. The significance level is denoted by the alpha is the probability of rejecting the null hypothesis when true. A significance level of 0.05 indicates a 5% risk of concluding that a difference exists when there is no actual difference. This means that there is a 5% chance that you will accept your alternative hypothesis when your null hypothesis is true. The smaller the significance level, the more proof required to reject the null hypothesis or to support an alternative hypothesis. Step 4 is to calculate the test statistic, the corresponding p-value in essence. Hypothesis testing, statistical tests to derive calculated values that compares groups or examines associations between variables. The p-value is determined based on the result of your test statistic. Your conclusions about the hypothesis are based on the p-value and your significance level. So for example, a p-value of 0.01, this will happen 1 in 100 times by pure chance if your null hypothesis is true, not likely to occur by chance. A p-value that is 0.75, this will happen 75 times in 100 times by pure chance if your null hypothesis is true, very likely to occur by chance. There are cautions about the p-values to consider. Calculate the correct sample size. A size directly impacts on the p-value. Large sample sizes produce small p-values, even when differences between groups are not meaningful. A small sample size can result in failure to identify a difference when one actually exists. So for example, average ages were significantly different between the two groups, 16.2 years versus 16.7 years, p equals 0.01, n equals 1000. This is an important difference? Probably not, but the large sample size has resulted in a small p-value. Average ages were not significantly different between the two groups, 10.4 years versus 16.7 years. P-value 0.4, the sample n equals 10. This is an important difference. It could be, but because the sample size is small, we can't determine for sure if this is a true difference or just happened due to natural variability in age within these two small groups. In step 5, where we draw a conclusion, we consider the p-value. If it's less than or equal to the significance level, the null hypothesis is rejected in favour of the alternative hypothesis because the result is statistically significant. If the p-value, however, is greater than the significance level, then we fail to reject the null hypothesis because the result is not statistically significant. Hypothesis testing is not set up so that you can absolutely prove the null hypothesis. Therefore, when you don't find evidence against the null hypothesis, you fail to reject the null hypothesis. When you do find strong evidence against the null hypothesis, you reject the null hypothesis. The conclusions also translate into a statement about the alternative hypothesis when presenting the results of a hypothesis test. Include the descriptive statistics in your conclusions as well. Report exact p-values rather than a certain range. So for example, the intubation rate differed significantly by the patient age, with the younger patients having a lower rate of successful intubation because the p-value was equal to 0.02. Okay, let's look at an example. The null hypothesis, there's no difference in survival between the intervention and control group. The alternative hypothesis is there's a difference in the survival between the intervention and control group. The alpha, the level of probability, is 0.05, or a 20% increase in the survival for the intervention group. The p-value is equal to 0.02. The conclusion is that we reject the null hypothesis in favour of the alternative hypothesis because the difference in survival between the intervention and control group was significantly statistical. There's a 20% increase in survival for the intervention group compared to the control group. In example 2, the null hypothesis is there is no difference in survival between the intervention and control group. The alternative hypothesis is there's a difference in survival between the intervention and control group. The alpha level of probability equals 0.05, 5% increase in survival rate between the intervention and control group. The p-value is actually equal to 0.2. Therefore, the conclusion is we fail to reject the null hypothesis. The difference in survival between the intervention and control group was not statistically significant. There was no significant increase in survival for the intervention group compared to the control group. P-value equals 0.2. So in conclusion, hypothesis testing is often perceived as complex, and it really does require practice. Basically, it's about making assumptions about population or populations, a process that involves choosing a level of significance, taking a random sample from a population, then calculating the sample size with an appropriate sample statistic. The researcher has to identify the sampling distribution of the test statistic, and based on the sampling distribution of the statistic, judge if the test statistic is too large or too small to be consistent with the assumption. So if so, the researcher rejects or accepts the assumption. Okay, that concludes this session in an introduction to the basics. There are 7 other parts to this basic statistics learn shop. And remember, it is just the basics. And you can get access to a lot of other information on some of the excellent YouTube videos. See you in the next session, and if you think this has been of any value to you, or any of the other Dr. Manny Learn shops, recommend them to your friends and colleagues. Thanks, see you soon.